Good morning. This is our demo for the Summer Open Mainframe Project Mentorship. Our project is the Improve Feilong Packaging Process. My name is Aazam Thakur. I'm a fourth-year engineering major student, and I'm the mentee for this project. I'm joined by my three mentors. I'm going to hand it off to Dongma.
Hello everyone, my name is Dongma, and I'm one of the mentor of this project. I'm the software engineer of IBM and also active contributor of Open Mainframe Feilong project. Eric.
Hello, my name is Eric Bischoff. I work at SUSE in Germany, where I am busy with quality engineering. And I was very fortunate to participate in this summer mentorship program. And also I'm an active contributor to the Feilong project, sorry.
It's okay, it's all right. Hello everyone, my name is Mike Friesenegger. I also work at SUSE. And I am the chairman of the Feilong project within the OMP. I live in the United States, and how about we go to the next slide, Aazam, and let me tell people a little bit more about Feilong. So Feilong is a software development kit that provides an API, a set of APIs for managing ZVM. And so ZVM is a hypervisor on the mainframe that has been around for many years. And typically you would manage ZVM through a console. You'll get to see here in a little bit more about the 3270 console. But it's not so easy to use the 3270 console. Many people today are very used to RESTful APIs and being able to do puts and gets and things like that. So what Feilong provides is a set of APIs that allows to programmatically operate with the resources that the ZVM hypervisor provides. Things like creating guests and deleting guests. We call guests virtual machines, or it can be called virtual machines as well. Dealing with images, storing an image, writing an image to the disk of a virtual machine, connecting the network to the virtual machine, adding disks to the virtual machine, and things like that. So those are all the different things that Feilong can do. Feilong is mostly written in Python, although there are some C components. The Python client library allows and makes it very easy to extend the capabilities of Feilong. That's a bit of Eric's contributions to the Feilong project, is around extending the capabilities through the Python client library. And really the goal of this summer mentorship project is to improve the packaging process. Eric's going to talk about that a little bit more in his part of the presentation. But to wrap it up, if you want to learn more about Feilong, go to the openmainframeproject.org at the link you see at the bottom of this page, and you can actually go to the Feilong project page. You can see a video that goes into a lot more detail about what Feilong is, what its benefits are to the community, why we are around, and also get to see a bit of a demonstration of Feilong and how it's being used within actually a product that is available to customers for enterprise deployments, as well as a demonstration of how you can use Feilong via the command line for curl requests and showing off the APIs. So I encourage you, after watching this video, to take a little bit of time and go to the openmainframeproject.org, find the Feilong page, and check out the video as well as the GitHub repo. So now I'd like to hand it over to Dongma to talk a little bit more about the repos. Dongma?
Yes. Actually, we are mainly works on two main repos. One repo is the Feilong GitHub repo, and it includes the source code of the whole Feilong project, includes the JSON, ZVM SDK, and the documentation. Another repo is the build ZVM SDK repo. This repo contains the main build script, specs, and the packaging stuffs in this repo. Also, we are working on the documentation. One is the quick start part, and another is the setup web server part. Aazam, you can highlight about the documentation.
This is the documentation snapshot that we've updated. Initially, this documentation only had information about the installation for RHEL. But after I've worked on it, we now have the installation instructions for both Ubuntu and SLES at their latest versions. Similarly, for the next documentation page, which is the setup instructions for the web server, it also had initially information only for RHEL, but we've updated it to include both SLES and Ubuntu. I'd also like to show you about the C3270 emulator that Mike touched upon. This, as you can see, is a snapshot of the emulator that we've used. This is what it looks like when we clone a distribution and run it on Feilong. You can see some of the commands that we've used, the CP commands and the CMS. And now I'd like to hand it off to Eric to explain more about the OBS and how we've used it for our packaging process.
Yes, thank you. I would like to go back to the basics first, because why do you need packages at all, after all? We have, before Aazam started, we had a nice documentation already about how to set up the server, install all the necessary software, and get it to run and possibly debug it. But that's not very convenient, and it's time intensive. Packages are the standard way in the industry and in the Linux world to package, to put together software. So it's easy to install, to remove, and to upgrade. It contains dependency towards other software components, so you don't have to care about that. And it also contains post-install scripts that would take care of configuring the configuration files and so on. So it's really a matter of convenience that makes the life easy for anyone who wants to install Feilong. And with that, we hoped to lower the bar for people wanting to install Feilong. Now, the scope was to create packages, but how? We decided to leverage the Open SUSE build service, which is also known under the name of OBS, and because it has a number of advantages that I would like to detail. So basically, OBS is a website that provides packaging as a service. Maybe you can show the screenshot. Yes, this is the web UI of showing how we build in OBS one of Feilong's packages. In that case, it was the Debian ZVM SDK, so the API. And this has a lot of advantages because first, it allows to build on several platforms, and S390 is one of them. That's very nice because someone wanting to build the packages does not have necessarily access to a mainframe. So only by dropping the data onto the build service, it can get recompiled and repackaged, rebuilt for S390. Another advantage is, despite it was this service was developed and is hosted by the OpenSUSE project. OBS also allows to target other operating systems. That includes Red Hat clones. In the case of Aazam's project, we based the works on Alma Linux, and also Debian family operating systems, in our case, Ubuntu. And in addition to the web interface, OBS also allows to build locally via a command line tool called OSC. So you don't even need to use the building server at OpenSUSE, but you can also build locally with one very same set of configuration files. And finally, OBS has automation capabilities, and that went exactly in the direction we wanted to take to enable automated builds of new versions of Feilong. And with that, I hand over.
I'll explain more about the web UI that you can see. What we have here is the web UI and the packages on the OBS. For each package, we have, under each distribution, we have two packages in total, Zthin and ZVM SDK. We have a total of 3 distributions, RHEL, SLES, and Ubuntu. So each of them have 2 packages themselves. That makes a total of 6 packages that we've tested and hosted on OBS. Now, let me explain more about automating the entire process itself, because we've manually now made sure that the packages can be built, automated it, so anybody can download them from OBS on their S390 system and use it. But how would we tackle the situation of Feilong itself being updated and these updated changes now being hosted on OBS itself? So for that, I've developed an intricate automating process that starts with the use of GitHub Actions. Here we can see that the Feilong repository has one GitHub action. It takes into account any changes that have been pushed to the master branch, and it dispatches an event to the build ZVM SDK repository, which is the repository we've primarily used for building the packages. Build ZVM SDK listens for any of these events, and once it receives a dispatched event, it has script files that it runs for each distribution and its own packages. When the script file runs, it creates artifacts of tarball of the Feilong repository, as well as .dec files that Debian requires, and it pushes them as artifacts itself on the Build ZVM SDK project. So you can actually see that these artifacts have been uploaded on the Build ZVM repository itself. So that's fine. Now we've automated the process, but how does OBS get them? So for OBS, there is actually a system of using a webhook. Now this webhook interacts between the Build ZVM SDK repository and the OBS virtualization subproject Feilong. What it does, it listens to any of the changes that happens on the Build ZVM SDK side. Once a change happens, there is a configuration file which triggers the webhook, and the webhook triggers the service files to be run. Now, what are service files? If you go to the previous, you can notice that there's a service file within the package. These service files are the files that OBS uses in addition with the webhook to trigger a rebuild of the packages. And these packages now use the newly created tarballs within the Build ZVM SDK repository to build the newly fresh made packages on the OBS side themselves. So now when a user wants to install and downloads the OBS package, they will have the newly built package, which is up to date with the latest changes of the Feilong repository itself, thereby simplifying the entire process of packaging. While these 3 months have been quite entertaining and hard in working on this process, there is scope for a lot more changes and a lot more things that we've encountered. And we've created a parking lot for these changes. One in particular is the documentation. Despite improving the documentation for all the three repositories, there's still scope for much more. In particular, the authentication side between the consumer and the BEOL server sub. A second part is the signing of packages. As you might have encountered while downloading packages, the signing issues security and authenticity. This needs to be touched upon for all the three distributions. Another part is for the spec files of ZVM SDK and Ztin to be uniform. This it makes sure that it's easier to update them for future improvements. And the last thing is there could always be extra work done on the GitHub actions to automate building. Some things like touching upon the automatic versions. So with a new release, we don't have to worry about updating the version numbers. That's a potential change that can be worked upon. Finally, I'd like to conclude this mentorship. It's been a hell of a ride for these past 3 months. It's been thrilling. There's a lot to learn. The mainframe topic itself is so vast, something it's fresh to me, and I loved every moment of it. Thank you.